Hey everybody, thanks for clicking on this video. Today we're going to be calculating distance between polar coordinates. If you want to follow along, the links to the companion worksheet are in the description below. Also, don't forget to click that subscribe button so you can stay up to date on all the new videos we have coming out from the channel. Now we've already dealt with the distance formula for rectangular coordinates, but here we're doing distance with polar coordinates. And you may think, well, why don't you just convert to rectangular? Well, you could do that. That's one way to do it. But I want to show you something that kind of uses another little tool that we've already dealt with. So first, let's draw these. So first we have 2, 10 degrees. So 10 degrees is right about there. And so there's that point. And then 4, 110. So there's 110 and 4. So 1, 2, 3, 4. Now what we're interested in is what is the distance between them. Well, what you want to think about is you want to think of this, you want to think of this, and you want to think of this, what we want to find as the lengths of 3 sides of a triangle. Now what do we know? Well, we know that this side has a length of 2. We know that this side doesn't have a length of 2. Sorry about that. That's a 4. And we know the angle, because this is 110. And this is 10. So that means this angle is 100 degrees. And so the distance, call it d, is what we want to find. So if we take away the axes and any excess drawings, what we have is we have a triangle. That's not a right triangle. We note 2 sides and an angle between them. And so what this is this actually is a triangle that we can solve with law of cosines. So law of cosines, I'll post a link up in the upper right if you want to review that, says that we take c squared equals a squared plus b squared minus 2ab cosine of c. Well, the side over here and the angle here has to match. And the one angle we know is 100. So let's put 100 in here. So that means this side has to be over here. So the two a and b's are 2 and 4. So 4 squared plus 2 squared minus 2 times 4 times 2 cosine of 100. All right. So what I'm going to do, I'm going to reach for my calculator. I'm going to type all this in. 4 squared plus 2 squared minus 2 times 4 times 2 times cosine of 100. And just to be sure, nope, I am not in degree mode, so that number is not correct. Got to be sure you're in you're in the right mode. Otherwise, your answers won't make any sense. There we go. That's a bit better. So d squared equals 22.778. So if we want d, the distance, we just take the square root of that, 22.778. And so our distance is approximately 4.773. So this is how we do this. We treat this as a triangle and we solve it using law of cosines. So let's look at this next one. So here we want to calculate the distance between these 2 polar points. So first we're given the angle of 25 degrees. So that's about here, except that the distance is negative, so I actually have to go back this way, going in the opposite direction, 1, 2, 3 spaces. So call that 3. And then angle of negative 160. Well, 160 would be over here, so negative 160 would be over here. Now the question is, should 160 be over here or should it be over here? Let's think about this. This is 25 degrees right here. So this is 25 degrees right here. So what angle is this? Well, if I take 25 away from 180, I get negative 155 degrees. So negative 160 is actually in there. All right, and then it's 5 units. So 1, 2, 3, 4, 5. Okay. Now what I'm going to do is I'm going to redraw this triangle because they're a little tight fitting in there. So what we have is we've got this side of 3, this side of 5. Now we said that this angle was negative 155, and we graphed 160. So this angle right here has to be 5 degrees. All right. So now we want to find this angle right there. Or sorry, this side. So we'll use law of cosines again. So d squared equals 5 squared plus 3 squared minus 2 times 5 times 3 times cosine of 5 degrees. So now what we get is so 5 squared plus 3 squared minus 2 times 5 times 3 times cosine of 5. And yep, we're in the right mode. So d squared for this problem equals 4.114. So d is the square root of that, 4.114. And we get 2.029. All right. So now, on the other side, we're asking, what is the value, what is the distance when we have these two? Now, this is really vague because we just have unknown coordinates. So, let's try and plot them. So let's say that theta 1 is right here, theta 1. And this length right here is r1. Now, let's say theta 2 is up here. Theta 2. And let's say that our distance right here is r2. And so our distance is d right there. Now, we still use law of cosines. And what we used is the same setup as numbers 1 and 2. So let's follow that. What I took is I took each of the r values, so that's r1 squared plus r2 squared, minus 2 times r1, that's this side, times r2, that's this side, times cosine of, now our angle is in here. It's not theta 2 and it's not theta 1. It's actually theta 2 minus theta 1. It's actually the difference between them. And because cosine doesn't matter about positives and negatives, we can write it this way. And even if we get a negative, cosine's all right. And so if we want to get the distance by itself, we can take the square root of r1 squared plus r2 squared minus 2 times r1 times r2 times cosine of theta 2 minus theta 1. And so what we have here is a generalized rule for finding the distance between any 2 points in polar. So if you want to, you can actually go back to the previous 2 examples and see how well this works for those other 2 examples. Thanks for watching. If you liked the video, please give it a thumbs up. If you have suggestions or problems you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching, and remember, the best way to understand something is to do it.